What's up, dudes? Welcome back to another micromotor workshop. The summer has left us in Australia. Last week's heat wave is gone, and today I'm wearing fleece and felt boots. So yeah, summer goes back to you, my friends. And before I continue my battery, or in this case, more pronounced plug testing, I just like to quickly recap what we observed last week. Um, the little explosion of the battery was just sort of the object of that, what I observed. But at first, it was kind of interesting that I posted the GIF what Scott created of that battery puffing up in my hand. I posted that on Reddit, and that was my most popular Reddit post ever. It's kind of interesting, you can invent the heck out of things and make documentaries with days of work, and then you have a battery spontaneously explode, and that's what people like. But yeah, I laughed at that a lot as well. So yeah, here we go. But what I also have taken from that is that a lot of people watch these live cast uploads after the fact. When I started that, I didn't even think anyone would be interested, even if it's live. But then down the track, I learned that quite a few of you obviously like it, and I learn a lot from that. So that's why let's continue. But also, many people watch that up to 1,000. I mean, that's pretty much nothing in comparison to, let's say, popular YouTube channels. But for some random 1 hour, 40 minutes upload, to have 1,000 people watching it afterwards, kind of surprised me. So that's why I thought I will also do a little bit more to address those of you who watch after the fact. So today's topic comes out of a comment on the live cast from last week. A comment not in the chat, but in the comment section. So after this live stream is over, it gets automatically uploaded to YouTube and is available as a regular video upload there, minus or plus the potato TV quality. So even though I still mainly do this for the live show, and invite you to participate in the chat room that I've linked. I will also start to form my content based on what I read, not only in this episode's chat, but also, well, I ideally try to address everything we discuss live immediately, and those things which you post afterwards in the comment section of the uploaded video, I'll try to work that into the next episode. So I know that many of you know a lot more about electronics, batteries, mechanics, etc. than I do. So I appreciate you teaching me. Let's move on. So at first, let me check if it's all working. Mr. Rebel says, clear as hell, thank you. Madman is back as well. People love explosions. Yep, that's good. I hope to provide some more. Just like a flight video, do a nice one, get a few K views, crash and explode, and you get a few million views. Exactly. So, the parents of Seru Lin Blue laughed uproariously, which I think it means they laughed pretty hard. That's good. Audio sounds better today for some reason. Yeah, I was listening to the last episode and I thought it sounds a bit crap. So if it sounds really crap, just tell me, and there's a few buttons I can press to hopefully make it better. I'm not listening to myself, because if you've ever tried that, that really drives you nuts. So if you want to do the experiment with yourself, just on Mac you can install Line In, and on Windows I'm sure you can install something as well, which allows you then to pipe the input audio, the microphone input, back to your headset. And usually, just because of the processing, it will have a second or so delay. And I think this is one of the most annoying things you can do if you want to upset someone who is trying to speak publicly and tries to make sense what he does. You get a slap back delay. Someone says, do I still have any issues here? Let me have a look. Change audio, it's only to Plantronics. Change audio, it's only to Plantronics. That's good. So to move on, I will switch over to the desk, the bench cam, and show you what my plan is. So at first, unrelated, but maybe interesting for some of you, I pulled the black heat shrink off two of the batteries and compared the weight. On the small 750 milliamp Hobby King graphene battery, you save about a gram with pulling the black stuff off, and on the large 950 milliamp, it's 1.5 gram. So last time I discharged those packs over the red JST plug, which got pretty warm at 10-12 amp. And the question that came up was, is the plug the bottleneck of that pack? Because as we've seen, there was not so much improvement as I expected from the 750 milliamp to the 950 milliamp. So in relation to their weight, the 950 milliamp performed worse than the 750 milliamp. So I've thrown it away. So let's see if I still have the piece of paper where I put the values on. Here we go. So instead of going back in the digital archives, still have my piece of paper from last time here. So we had 13 amp out of the 750 milliamp and 15 amp out of the 950 milliamp. So that was 0.65 amp per gram and 0.58 amp per gram. So slightly less performance per weight out of the heavier battery. And that could very likely be due to the plug being the limiting factor. So next to removing the heat shrink for checking how much weight there is to be saved, I've also cut open the top part of the smaller battery just to check how the wires are attached here. And as you hopefully can see, the two plugs are just soldered in parallel to the relatively fat battery tabs. So I have some confidence that drawing through the two plugs at the same time will allow more current to flow and create less heat in the plugs, and therefore will give us a few interesting values. For example, is that pack getting stronger in relation when we pull through two plugs at the same time. And also, is there a difference to be observed when we use just the red JST plug and or just the white Losi Valkera plug? If I look at the wiring, the wires going to the red plug say 20 AWG, and the cables going to the small plug say 24 AWG. So the lower the number, the thicker the wire. So that means there's a little bit thicker wire going to the beefier plug. That means, well, we probably can expect to be able to draw less current through the smaller plug and generate more heat. And it also means we'll probably not half the resistance by adding this plug, but yeah, just change it a little bit. But yeah, the main thing what I expect from that experiment is to see if I only discharge it over this plug, and then with both in combination, do we get different values? Do we get a higher discharge rate? So to do that, I have made up this adapter here. It's actually in both cases 20 AWG, 20 gauge wire, which is a little bit difficult to crimp into those white plugs. That's why I understand why Hobby King does it this way. If you want to crimp 20 gauge wire into those Losi plugs, you can't crimp the insulation into it as well, but just have to have it sit flush with the crimp. Yes, I thought about doing this on the air as well, but it takes a while and it's probably too boring. So rather than watch me crimping, you can maybe watch some more batteries explode. So far the plan. I have a quick look at the chat room if there's any last minute suggestions. So it just dropped out. Oh yeah, so the video transmitter is having a bad day. That's right, I observed that as well. Kind of strange. It's exact same setup what I usually use, and I've observed that as well. It's dropping out. But when I'm sitting at the bench, I'm facing with my back to the monitor, so I can't see it. So Mullet is skeptic and saying the gauges of the wires won't make much of a difference. Yeah, that's probably right. So the main difference I expect to see is if I draw just from one plug or from two at the same time. If that makes a big difference, that means one plug is, or this one plug is not big enough to allow all the power that the battery could provide to go through. So no one has any objections. Let's try it. So I have this adapter here. I use EC3 plugs for most of my adapter connections. So on almost all adapters I fit EC3 plugs from Hobby King again. We can get them elsewhere as well, but I think they somehow originate near Hobby King. They're bullet connectors with a plastic housing where you can push them in. Very easy to solder and very good current ratings for their size. So as you can see, they are way overkill for these little batteries. They're almost as big in diameter as the plugs that go into the charger, and they're rated, I don't know, 40 amps at least, probably more than 100 amps at much higher voltage. So way overkill from here to the joint. So instead of making a whole lot of different adapters, on all my adapters I put the proprietary end on one side and then a EC3 plug on the other side, so I can make whatever adapter I need on the fly. They have the polarity marked on the plug as well, so you can quite reliably make them up without stuffing things up too often. And what I have coming out of the other end is one Losi Volcara plug with 20 gauge wire and a red JST plug also with 20 gauge wire. So the test will be, I run one battery, discharge it with just over the red JST plug. Well, actually we had this value from last time, so I could just take that value, which was, I estimated, okay, I only estimated this 13 amp. Okay, let's do the test from the start and increase the discharge rate to a maximum of 16 amp. That also means that the cut-off current will be 8 amps, so we will not measure the whole capacity or the whole usable capacity, but yeah, that doesn't matter. I'm just interested in the maximum punch. So 4.175 volts and discharge target 16 amp. Let's see how much you get. Are you sure? Well, let's put it a little bit closer. You see it like this? I hope so. So yeah, the interface reminds me a little bit of Windows 3.1. Yes. So here's the current rating. Goes up to, so I'm interested in the maximum value it reaches before the battery starts to drop. So 13, 14, 15, wow. 15.7 amp. Wow, that's actually more than I expected. So 15.7 amp. And then it quickly starts to drop. 15.7 amp, and after 30 seconds it was at 13.5. So that's all I wanted to know. Stop. So now let's connect the second pack. Now the interesting moment, if I have wired it wrong, plugging it in now will short the battery and be quite spectacular. Oh, this plug is tight. So because it's so tight, I will plug it in first into this adapter, and when it starts burning off, then it's easier to throw. So black, 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 red, red. Should be good. Nothing happened. So plug it in here. And again, 16 amp discharge. Ten, 12, 15, 15.9 actually hits the 16 amp mark. Stays there. Wow. Stays there for, well, it's now already 30 seconds in. Now starts to drop after 40 seconds. No. Recovered. Still pulling 16 amps after 1 minute. Still going strong. Fluctuates a little bit. Goes down to like 15.6, but then recovers again. Continues to pull almost 16 amp. I think I can pull this thing even harder. Wow, 1 minute, 30 seconds, still pulling 16 amp. Now I think it's starting to drop. 15.6. No, still. As soon as the voltage drops a little bit, it's enough for it to recover. Still above 15 amp after 1 minute 50 seconds. Two minutes. Almost 15 amp. Two minutes, 20 seconds, and it just dropped below 14 amp. Let's see how hot it is. Well, the plugs are just both moderately warm. The battery is actually warmer than the plugs. Two minutes, 45 seconds, and it's just dropped below 12 amp. So the cutoff is set to 8 amps now, because it's 50% of 16 amp, the starting current. So we're almost there. 9.0 now dropped, now 8 amps. Wow, that discharged the pack in 3 minutes and 5 seconds, and it stayed over 14 amp for the majority of the discharge. I think that's a very good indicator that the plug indeed is the bottleneck. So, what do you think? Should I repeat the same test to confirm that with 950 milliamp packs? Or should I run one from one plug and the other from the other plug? I only got one shot left because those two packs are now discharged. Takes at least, at least half an hour to charge them back up. And ideally you want to have them rest a little bit. So I won't be able to test those two again today. But yeah, with these I can either do the same test again to confirm that what we just saw, or I can run one test with the small plug and one test with the larger plug to see how they both compare. Let's have a look at the chat room. So JG thinks it's a successful experiment. Madman likes the 15 amps. So yeah, no smoke has been provided. Master RC student asked me if I've flown them. No, I actually have not. Madman likes the charger. No, it's actually not 400 bucks, but yeah, it's not cheap. I think I paid 280 or something for it. 2 plugs for the win. We need an XT15 plug. Yeah, so I know the XT30 plug, and I know that that's quite big. So Reco 555 votes for one Losi connector and the other repeat 2 plug test. You already did a micro JST test, did I? I tested them both together. So yeah, so what do we do? Either the same experiment again, so 2 running together, 2 running together. Oh no, hang on. One only this plug to confirm the last reading. It's actually even more interesting if we do this with the stronger pack. Assuming that these packs can deliver more current than the 750 milliamp, the difference should be even more significant. Oops, mail time. Morning. Sweet, thank you. Yeah, that's just stupid. Thanks. So, yeah, sorry, I didn't receive anything. Send something, so complete moment. Yeah, so by running the same test again, I think the difference in regards to the plugs, what I'm mainly interested here, will be probably even more significant. Let's try that. So again, last time we probably haven't been hard enough on the larger batteries. I've put 15 amp here, which was the value we got to with just the one plug. So that's why let's crank it up even more. And to still get a usable capacity reading, I will change the relative cutoff current, if I remember where to do that. Manage, edit, but not this one, this one. Manage, edit, discharge, and then here, end current. It's set to 50%, so let's set that to 30%. Back. Save. And now discharge at, oh, I need more than 16 amps. So if it already has hit 15 amp before, then how much should we give it? If it's at 20, then 30% of that will be how much? 6.5. Well, that's quite low. Can you go higher? Let's go to 24. So, what should we do first? Well, let's do it like I did the other one. just the JST plug and 24 amp. So current rises to 10, 13, 16, 16, yeah, pretty quickly. Just a few seconds. It arrived at 16 amp, whilst the 750 milliamp pack with only the JST plug peaked at 15.7 amp. So that's an indicator that the plug is indeed the limit. So after 1 minute, almost 14 amp. So the cutoff is set to 30% of 24 amp, so that's how much? 8. Still far away from that. 13 amp after 1 minute, 30 seconds. And I didn't mention it today. The charger tries to keep the voltage at 3.3 volts. So that's configurable, but I thought that's the value what makes sense. Putting the battery under quite heavy load, but not that much that it will explode every time. The plug is hot, so this time the battery is not very warm. Yeah, almost no extra heat to feel. But the plug, yeah, the wires are getting very hot here, or here in the back it's getting even hotter. So 2 minutes 30, still going strong at just crossed the 11 amp mark. Or discharge 550 milliamps. So I'm sure there will be another 200-300 to go. So after 3 minutes, we arrive at 11 amps. So yeah, it wasn't so much stronger at all than the 750 milliamp pack on just the single JST plug. 3 minutes 30. Still, oh no, it dropped to almost 10 amp. Now crossed the 10 amp mark at 3 minutes 40. 750 milliamp discharged. Getting a little warmer now. Not much. Four minutes 10. 9.5 amp. Now crossed the 9 amp mark. So not much more to go. 8 amp is the finish line. 850 milliamp. Yeah. Just getting slightly warm. The plugs now have cooled down a little bit as well, so 8 amps going through them does not seem to be much of a problem, but 16 amp certainly heats it up. So we have arrived at 902 milliamp with a cutoff voltage of 3.3 volts and a cutoff current of 8 volts. And as you maybe can see, the voltage is already recovering, so it's now back to 3.65 volts. So I'd say that was a relatively gentle discharge for the thing. Let's see how much we can crank it up by connecting both of the plugs. So just to recap, the peak value was at 16 amp, dropped to 14 amp after 60 seconds, dropped to 11 amps after 3 minutes, 180 seconds. So that was just the JST, and now 2 plugs. Quick look at the chat room. Light is glaring off the screen. Oops, I'm sorry. Caps lock problems. Madman is getting excited. That charger can mix a beat, yeah. Come to that later. It has an interface for that on the side. And Complacent says he has somehow pulled the strings to implement manual in-flight PID adjustment into clean flight. So definitely excited about that, to put this on my hex and my octocopters. So back to the ring. So I'll put this close here. Check, is it readable? Hopefully. So now comes the large 950 milliamp pack. So it's the same like this one. I just have taken the heat shrink off, connected over 2 plugs, and discharged with a maximum. Let me just write down here. We got to 902 milliamp capacity. So discharged with a target current of 24 amp, and again cutoff voltage 3.3 volts, cutoff current 30%, which is 8 amps. Discharge. So current ramp goes up 5, 10, 15, 18, 22, 22.4. Wow, 22.4, and then drops to 20 amp after 30 seconds. Yep, 30 seconds is what? 20 amp after 30 seconds. Stays above, oh no, 18 now after 45. 55 seconds, still 18 amp. 1 minute. Just crossed the 18 amp mark at 1 minute. So instead of 14, we get now 18 amp after 60 seconds. Yep, pack is getting warmer now. Not warmer yet than the other one was at the end, but for just 1 minute, it's already still feel some heat. Whilst the plugs, yeah, they heat up too, but not as much. So similar symptoms. We are at 1 minute 45, and maybe you already hear the charger howling. That means there's a lot of energy to burn. It switches on the fans. 2 minutes, and we just crossed 16 amp. 16 amp at 120 seconds. I didn't note down the 120-second mark on the previous pack, but we had 11 amp after 180 seconds. So 2 minutes 30. Let's see how far we get down. I mean, there's less resistance, so there can be more current flowing, but that also means that the pack is discharging quicker. So towards the end of the curve, we might see less current, even though the wiring has less resistance. But let's see, we're getting close to the 3-minute mark and still above 13 amp. Yep, crossed the 3-minute mark, and it was still sitting up just a few seconds later below 13 amp. So 180 seconds, 13 amp. That means over the first 3 minutes of the discharge curve, the pack provides 6 to 2 amps more than with just one plug. That's a huge difference. Why did we have it went below 8 amps? 3 minutes 42 seconds and 934 milliamps, but yeah, it looked like the cutoff didn't trigger as quickly as last time, so that will cheat a little bit on the capacity rating. But yeah, apart from that, it doesn't really matter. It recovers a little bit slower now. On the previous pack, we've seen 3.65 volts after a couple of seconds after the charge, and now it's sitting at around 1/10 of a volt lower. But I mean, that's to be expected if you can draw more out of it. Usually the pack will take a little bit longer to recover. So yeah, I think pretty impressive. That means if you want to fly a brushed micro hexacopter or octocopter, these plugs are certainly not enough. And even if you want to fly a high-powered 8mm brushed quadcopter, yeah, I think you can really get an advantage out of putting a bigger plug on there. So yeah, to recap, instead of 16 amp max, the large pack went up to 22.4. So yeah, here you go. Might not be really essential. I think we're just getting away with using them for a quad, but if you're really serious about this, you can get some more performance with the bigger plug. So what do you think, guys? Last things, there are quality differences on the red JSTs. That's right. I think there of course might be different quality plugs, but yeah, this also might just depend on, the individual crimping of them. It's just little wire tabs which are pushed into each other here. I've seen the XT30 plugs, but they're a little bit too big. So Madman talks about 1S brushless micros. Well, the problem with brushless micro motors is that they usually have a quite low voltage or quite low kV rating, so you need a lot more voltage. So someone was talking about an XT15 plug. Is there something like this? No, I just made this up, right? I only find an Omni XT15 mobile computer series. XT30. I've seen some people using them on micro plugs. Someone knows how heavy they are? Oh, look here, our friends at Multi-Rotor Superstore sell them. $6.99 for 5 pairs. Does it say weight? No, of course, they are precise as usual. No weight stating in the description. XT30 weight brings me to Weight Watchers. Let's see if Hobby King knows what they are worth. Hobby King only wants $3.88 for 5 pairs and tells us that the weight is 0.7 gram for the male and 0.1 gram for the female. 0.7 gram is a set. Nice little bullet connectors. The amp continuous. Don't need that much, so yeah, I understand why you came up with XT15, XT20. JG asked Hobby King for XT15, and what did Hobby King say? Everyone wants XT15 plugs. So yeah, I want XT15 plugs as well. So that was the plug testing for today. So the remaining question still is it just the plug? Or is it also the wiring? I mean, as one next step is I could just cut off the connector with the thicker wire and just solder another EC3 right next to it. And we'll find out if it's the plug or the wires. In this case, we combined a 20 and a 24 gauge wire and went up by around 40%. So yeah, it might just be the wiring as well. Oops. Camera problem. Let me see. Yep, indeed. Just unplugged the battery of my little FPV camera here. I'm sorry for that. So I see a scale here. It says 1.7 gram. Hobby King is right. Wow, 1.7 gram. That's a lot for a plug. 1.72 gram for 2 of them. Big plastic housing, big bullet connectors. Yeah, we need XT15. So yeah, that's it. plug testing done. Just to quickly recap on the status of my other main project. Some people have been asking me about it, and I won't have as much time as I wanted to do all the build either in videos or in the live stream as well, but it's actually pretty straightforward. So I use these FR632 receivers, small, cheap, diversity, automatic channel searching, and also now available in 40 channel version including race band. So this is a spare in case one of those here gives up. And obviously I didn't finish the wiring yet, but these are 4 of those receivers just glued to this video surveillance video recorder thing. You can get them in all different brands. The thing what you want to look for is when you buy them, 4 at least. This one has 8. I put them inside. 8 or 4 analog video inputs and 1 digital. Sometimes has an analog out as well, but 1 digital output. That's the important thing. Many manufacturers, or let's call them shops, sell these and just put the same board into a different housing. Just search for 4CH for channel or 8CH DVR, and look for a picture of the backside. And if you see 4 or 8 inputs on this side, then an HDMI out here and network and power over here, it's pretty much always the same board. It's just a small PCB in here in the bottom. I tried to put those 4 receivers in the housing, but unfortunately 4 of them are just like 10 millimeters too wide. So instead of hacking the case apart, I've just decided to stick them to the outside with wall mounting tape. The expensive stuff, the clear stuff, it just never lets go. So to get this apart again, you have to make some serious effort. For example, just taking a blade and cutting between them. It's almost as good as screwed on. So the video signal of all those 4 will feed into those inputs here. I'll have to somehow make up the wiring here. So I plan to drill a hole in the middle, feed all those wires through, and then there's another 4-port analog input which I have turned around and put inside. So then all the wires can go in here neatly and go into the inputs here. And then from that HDMI output, the signal will go into this EasyCap HD video capture thing. Has 1 HDMI input and 1 HDMI output, so you can display the signal at the same time while recording it, and it records onto USB. So I haven't really checked it how much memory you can put in there. I successfully plugged a card reader with a 16 gigabyte SD card in here, but that doesn't get you very far, so I will check if I can connect like a 100 gigabyte portable hard disk to it, and then stick those 2 things with the wall mounting tape here, and then wire it all up. And well, probably should say again what the reason for this thing is. It will then allow to record the 4 video streams we used to race on, to record them at the same time, and this way make a relatively cheap timing and judging system for FPV races, because how do you judge, how do you referee, if that's the right word, a FPV race? And since there's now a good amount of prize money to be had, I think people will try everything they can during and after the race to score some points. And this guy here will provide the information for the judges, and also for everyone to watch afterwards for some entertainment. So yeah, it's progressing. The only thing what's still missing to complete this build is a 12 to 5 volt step down, because all the parts, the video encoder plus the receivers plus the to be installed antenna amplifiers, will run on 12 volts, but only this sucker here runs on 5 volts. So needs to put an extra step down in here to run that as well. So yeah, I tried to put the step down in the wiring for that inside as well, so it actually looks like a halfway professional installation. So if anyone is interested in that, ask some questions, or turn up to tomorrow's race in Revesby, where we will put this thing into action again. I apologize for not even uploading the last stream, but I just got so busy with so many other projects. So enough of the bench. Answering a couple more questions of the chat room. So yeah, the video was down. I'm sorry. Scotty is building an Atom by the looks. I still have one as well. I didn't build it. What receivers am I using? Asks Mullet. You mean for FPV? Yeah, I'm not sure if the comment came before I actually showed this. So they are FR632 diversity receivers from Banggood for, I think, $50. Daft Punk. Where's the sequin glove? I don't understand what you mean, my friends. Is Ben's check the same as Michael Jackson's? I don't know what you're talking about. Now we are probably not live streaming the races, at least at this stage. I don't think it's possible at this stage, but yeah, down the track, once we figured out how to reliably record them and use the footage for the audience and for the officials and pilots on site, then at some stage I think we can hook up a live stream to the back of it. But yeah, I'm not really sure how interesting this can be made, because it's like a at least 3, probably 4-hour event, and yeah, it would be difficult, I think, to make this interesting for spectators. But yeah, we figure something out, because yeah, building and maintaining all this stuff already exceeds my capacity. I need some assistance with editing and broadcasting this stuff eventually. So I think I will limit my my work on these events to providing the stream, and then yeah, I think that's a clean interface. If anyone wants to do something with it, just hand out either a additional HDMI stream for live purposes, just yeah, an HDMI splitter, and someone else can have the signal, the complete signal I capture, or yeah, just provide the data afterwards, and you can do whatever you want with it. But it's massive amounts of data. So last time the data I captured from the event was like 60 gigabytes. And yeah, if you convert this, it easily explodes to a few hundred gigabytes in the editor. So it's quite a massive task, not only for the human editor, but also for the machine that's running on. So yeah, I've seen people have done it, so it is possible. And yeah, Scott, I'm sure we will work it out eventually. We're just um, in the very beginning of this industry. Um, I guess quite a few of you have experienced um, um, the dot-com bubble in the beginning, and yeah, this multi-rotor industry feels similar to me, but we have the advantage of already having a social media, social digital communication infrastructure set up. So that's why the growth of the multi-rotor industry will put the explosion of the dot-com bubble to shame. Robot Wars. Yeah, Robot Wars. I think I've seen Robot Wars. Not sure exactly what you mean, but just RC robots fighting. Yeah, actually, I have been to some robot fighting events in our local university. That's fun. Mr. Mullet, for editing, I use Final Cut Pro on a Mac. A lot of my videos used to be edited on iMovie on a MacBook Air. Now I switched to Final Cut Pro on a iMac. Frequent Flyer RC YouTube gives a shout out to me on his latest build. Cool, I didn't see that. I always like watching his videos, so I put this on my watch list for this evening. Scotty likes my race server. Yeah, it has been very well received. It's quite interesting to, yeah, not only for judging purposes, but primarily for just spectating. So I think this four-way ground station really turned the otherwise relatively, for spectators, boring event, because they only stand on the sideline and see some people staring in their goggles and some parts splattering around the track. But there, that really turned it into an event where you can kind of participate and watch the stream and cheer for your favorite pilot, or just observe the crashes also from the onboard perspective. So, and last, I'm still looking for participants for my trip down the coast. So quite a bit of my time last week was invested into getting the car I bought ready for the trip down the coast. One of the main challenges was to get the annoying smoke smell out of the car. So that wasn't my fault in this case. I bought the thing like that and didn't really notice how bad it is until a few days later. So it's a Japanese direct import, and as Japanese people obviously like to do, it was chain smoking in the car. So I have blasted the heck out of this thing with a ozone generator. So I can only recommend that. If your car smells or your workshop smells like, for example, roasted batteries, you can just run a ozone generator in it for a day or two, and it smells like nothing ever happened. I can strongly recommend that. So, yeah, let me see if there's more questions coming up. Otherwise, it's 12:40 p.m. already my time. We'll call it a day early and move on to, well, I have a lot of stuff to send again. It's Monday morning. 4 to 60 windows down at 60 mph. I don't know what you mean, Adam. Yeah, JG, I heard that only the ozone, if you do ozone properly, it does not attack the plastic. So there's different ways of creating ozone, and if you do it properly and don't create some byproduct acid stuff or whatever, I didn't understand how exactly it works, but the guy said he's using the good ozone. Yeah, if you buy a cheap ozone generator, which generates some byproduct, you might dissolve the plastic. But if you have the expensive stuff, you can apparently blast the heck out of it, and it only attacks organic life forms. Don't know if there's So it only attacks life forms. So afterwards, everything is dead in there. Yeah, exactly. Just like the Chinese packages, everything out of there, they just love smoking. Incredible. So there's some more questions before I go from Papyrus, but there's one more question from, you have a funny name, Seru Lean Blue, asking what's the largest frame battery size you fly FPV. Well, seriously flying, I only do this size. 8mm motors, selection of various frames, 10-gram FPV gear, and 480 milliamp my lipo packs. That just works so good. All the other things I do is sort of experiments on the side, but that setup is my daily driver. And but yeah, if you ask for the largest is a micro octocopter with which runs on. Previously, I've also run this on the 480 milliamp packs, but that's probably the candidate I will try those juicy 950 milliamp packs on. So this thing is quite heavy because it carries FPV gear on top and an 8x8 camera on the bottom. And I always thought, it's a little bit weak with the 480 milliamp pack, although it flies for around 2 minutes and takes some good footage. But it certainly has more payload capacity. So yeah, that's what I'm going to test these batteries on. And yeah, I have to figure out if I do something about the battery plug. This thing actually would not have much of a problem with carrying 1.7 gram extra if it gets more punch out. This weighs almost 100 gram anyway. So JG says when you treat water, you end up making peroxide in the water. For air use, it should be fine. So that's in regards to the ozone. Yeah, well, it worked well. It doesn't stink anymore, and created a kind of a little bit of a film on on the plastic. Oh, it's again mail time. This time I'm getting something sweet. Hello? Good, yourself? Thank you. You too, see ya. Mail time. What can it be? What can it be? Okay. Not again. I'm sorry. So, yes, this is the MJ666 frame from our friend Michael in Germany. He makes nice carbon frames, quad hex, and octocopter. So if you want to look him up, MJ666 is his RC Groups handle. And yes, this is the one I flipped 30 times in the backyard because the clean flight controllers seem to go crazy if you flip them too fast. Maybe that's fixed with the latest firmware, so that was probably a year ago. Yeah, these frames are indeed the tank. They take a beating. Very nicely engineered motor mounts. Very difficult to install though, so I recommend if you get a frame from Michael, you also get a little vise to mount the motor mounts. And it's not a quick fix on the field. So if you break a motor or rip a cable or something to replace that, yeah, it's a good amount of work. You can't do this just with your fingers or some handheld tools. Well, at least I struggled just doing with a pair of pliers. No. Yep. Mullet agrees, so he has seen one of these frames already. It's a major pain in the behind to put the motor mounts in, but once they're mounted in there, yeah, it's just very solid. There's like little tabs which need to be pressed in to push the mount into the frame, and once they're in there, you push the motor into the mount, and that locks the tabs into place, so the mount cannot leave the frame without the motor previously having left the mount. So yeah, very sturdy construction while it's in there. The problems on these motors is that the end caps can pop off if you apply pressure to the shaft. That's completely avoided by these mounts because it locks in the caps, and it just clamps those motors so tight there's just no way with getting them out of there by hand or even with some handheld tools. If you want to try to get them out with pliers, you will either break the end cap by pushing in there, or you will bend the motor housing by trying to crank on it. So I have printed a few special parts with holes in there and holes in there to mount it in a vise to push it out completely axial aligned. Otherwise you will break these things by trying to mount or dismount them. So you have to push them out with some metal pliers. Yeah. So if you have some more ideas how to do it, please post some pictures or videos. I figured out a way now, but it's anything from convenient and quick. But on the upside of that is once you have the the amounts in there, it's very, very tough. So that's it for today. If you have more suggestions for topics in future episodes of the Micromotor Workshop, please post them in the comments below after this video has been uploaded. So if you are watching the live stream, just wait a couple minutes after I click the stop button. YouTube will automatically upload this, and if you're watching after the fact, just go down while the video is playing and put your comments below. I will read all of them. Thanks for watching. I see you guys later.